raise your hand on the teams. Normally, I'll go quickly, and if I get distracted, probably if you speak is better for me.
Okay.
So let me switch to the presentation. Um, I'm Senior Director of Technology for WESCO, Utility Technology. I'm electronic engineer, working automation for almost my whole career. In the last 15, 20 years, I've been managing companies selling technologies. So I understand all the nuisances around technologies, and an approach to technology is really down to earth. We try to be a consultant and give our best interpretation of technology. So this is the agenda that we put together. We're going to talk about current AMI and AMR systems. This is probably a boring module. You know probably more than me about that, but the idea is to set up the vocabulary, expectations, and frame the second part of the presentation, that is understanding your current system, uh, framing what we call the technology evolution curve. There's an evolution of technology, and we have our view on that evolution. And finally, how we need to understand the needs of data, why we need data, and how to get grid insight, taking advantage of the AMI systems. And finally, a couple of closing remarks just to wrap up and finish. Um, Current AMI and MR systems. AMI started in the 80s as a way to communicate, collect, analyze energy usage, and communicate with meters, electric meter, gas meter, and water meters. Every time we talk about AMI, we're talking about the meters, the network, the software, communication, integration, any type of displays that may be integrated into AMI, meter data management software, and of course, CIS, the system that the utility used to manage their business. So every time we talk about AMI, we're talking about all those components. Uh, from last decade, MDMs have been um, more popular. Refers to software that do the long-term data storage. When you have a head end, an AMI with a head end typically is short-term storage. Some systems is 5 months, some other 3 months. I think the one with the largest short-term storage is 1 year. After that, if you need more years in your database, you need to buy an NVM. It's the only way to store information and do the analytics. And typically, that NVM, the data is usage data, events, alarms, not only the readings. Acronyms, tons of acronyms. We're going to use these acronyms along the presentation. If you have doubts about one, you can ask, but our the typical acronyms you'll find are here. So as we said, AMR, AMI had been evolving since the 80s, and the initial focus was to develop a tool to collect accurate readings and timely consistent. Back in the days in electromechanic meters, you need to go to read the meter, and it was a manual operation involved. That means prone to errors and problems. So the AMI, the first attempt was to collect accurate meter readings and consistently. You don't need to wait for the weather to be safe or perfect conditions to go and read. That was the initial goal of the technology. But as communication technology improved, there was a added functionalities, increased functionality for those systems, and most of the advances probably 30 years ago were considered impossible, like uh, read any meter on demand anytime, uh, improve readings, no errors, remote disconnect, prepaid metering, uh, it's an easy way to handle difficult counts. You can use certain meters as bellwether meters, and you can read voltages across your low voltage line. And finally, every time a meter is disconnected, you get a message, so you can map outages much more efficiently. So we started trying to read meters better. Now we're in a position in which we can extract much more information from our meter install base. One of the first that is now obsolete, and probably this is the only technology that is really obsolete, is power line carrier one-way. System use the electric cables as the communication network, and it's a low frequency waveform embedded in the cables. And with this system, it's a system that is really slow. You can only read meters. There's no way to send commands to the meter. It could take hours to get all the readings to the head end or the utility. And it's a very, very limited register functionality. Registers, we talk about, variables. You can read probably one, and that's it, kilowatt hours and period. And there's no way to do a remote disconnect function. So essentially, it's a system that is obsolete, and there's a few still working, but of course, it's difficult to get parts and meters. An evolution of that was the two-way systems, the PLC two-way. You communicate back and forth, and all the problems of the PLC one-way are over. We can read multiple register. You can do remote disconnect, even prepay functionality. You can put meters in an OMS. And a good thing that it was not possible before is date and time are synchronized. You can synchronize the meters, stamp the meter, so all the meters can have a standard clock. So PLC two-way is healthy, is working, is supported. It's a very, very good system, and we see that manufacturers are going to support this system for a long run. You're familiar with this. This is how it works. You're going to have a database, a server, a communication line to the electronic equipment and the transformer that injects the signal into the cables and is able to read. So the signal goes through the power lines up to the consumption point, where you can read the meter and eventually even control load controls and even in-home displays in certain cases. This is a full-blown PLC two-way system. The most common use is just read the meters and not do much more than that. Any questions up to here? Okay. An evolution of the AMI, AMR was the drive-by and walk-by. In this case, the meters are constantly transmitting the billing register, and you need to be close to the meter with a collector, data collector, even in a truck or a handheld, to read those variables. Up to 3 registers are supported, and there's a way to do a two-way functionality, but forces you to be close to the meter, which defeat the purpose. So going to the chart is as simple as this. You have a collector on the truck, you drive by, and you collect the information. Information is then downloaded when you get to the office. In some cases, if you have a cellular card, you can upload straight to the cloud. So those are the most advanced features on AMR systems doing drive-by. Then we go to the most advanced system, the system that any utility probably will be deploying if they start the project today. 3 technologies, RF point to multi-point It's essentially a radio that can work either on register spectrum with a license or in the open spectrum, unregulated. You can have a second technology is a mesh network. The mesh is, as the name implies, is a topology where the meters talk to each other and the information goes from one meter to the other. This is a technology that was created for military purposes. That was the first use of the technology, the mesh technology. And finally, although it had been in use for about 10 years, it's not still 100% popular, is cellular. The old 3G fiasco that some utilities experienced when a ton of devices were discarded and moved to LTE or 4G prevented the spread of this technology. But now we are in a very safe place with the Cat M1 standard. It's a version of LTE, is here to stay. And it's essentially is not the same as the 5G, although probably you'll see the antennas in the same tower. It's a completely different network created for AMI, created for this type of application. So these are the three basic technologies. And there's cases in which you can do a hybrid or mixing two. You can have for example, a PLC two-way and cellular to cover certain regions in which you prefer. You have 4 or 5 meters. You are not going to put all the substation equipment for 4 or 5 meters. You just simply put a cellular meter and you can read those, and it's much more convenient. So point-to-point RF network. You'll have a data collector unit. Typically, you put that data collector unit in an asset. It could be a utility asset and a city asset. Normally a tower. It could be a building. It could be a pole. And the meters will talk to that data collector unit. And here's one of the interesting things about these RF systems is redundancy. The concept of redundancy is, for example, this house here can talk to 2 different data collectors. Then in the head end, the information is sorted and they pick just one of the data sets. These data collector units are connected to the cloud or Ethernet, either by cellular backhaul or fiber backhaul. You can buy these data collector units with the 2 connectivities. Suppose you are in a utility that you have a very good fiber and you have fiber deployed all over the place. Well, you don't need to go cellular. You can use your own fiber to do the backhaul. But if there's certain areas where you don't have the fiber, you can go cellular, and these data collector units will be backhauled to the head end using cellular. When you are ready to request for quote a new system like this, one of the key variables is the redundancy. You may ask, hey, I want to have redundancy in all my meters. That will increase the cost. If you said, I want just redundancy for 80% of my meters, automatically you have less DCUs and you have, of course, less redundancy, but the cost of the system is lower. So that is a variable that is important to specify when you are requesting for quote or budgetary quote on a system. Questions up to here? Good. So mesh system, you see all the meters talking to each other. Some meters accessing directly a router or an access point. And the information goes from this meter, in this case, to a street light control relay and finish in the head end. This is one of the path. you can have secondary path. It's not active, but it's a possible path. Suppose you have this meter going through these hops. You can count 1, 2, 3, 4 hops. That's another variable that you normally plan when you're designing a mesh architecture. How many hops do you want? More hops, the farther the meter is. And you talk about a deep mesh. The deeper the mesh, the longer it takes for the message in the last meter to get to the head end. So suppose you have an interruption, either because you lose the backhaul in this access point or the meter is disconnected. So the mesh that is self-healing, self-correcting, automatically will use the alternative path. So this is one of the beauties of the mesh. Suppose you have a truck parked in front of a meter and the reception in that meter is not that good, the mesh automatically will route through other path. So, and finally, cellular, pretty simple. You have the meters. It could be electric, water, gas. In some cases, you may need a gateway. In certain cases, to get to the 4G LTE or Cat-M1, that goes to a cloud, and from the cloud straight to the head-end software in the utility. The topology is pretty simple. So going quickly, you have the RF point multipoint. We talk point multipoint because from one data collector to multiple meters. Mesh, which we have a group of meters talking to each other. And finally, the cellular solution. In the case of a cellular solution, you don't need to install any network. The network is there for you. It's either Verizon, AT&T, so you don't need to maintain any gear on the street. If you go to mesh, you need to maintain the data collectors, the relays, and the like. So if you go and you decide to use a AMI solution with cellular, you don't have any assets to maintain. Of course, you have the cost of paying the carrier for the service. So in a nutshell, this is how the system works. You have meters getting to an access point, the DCU, gatekeeper, it depends the name the manufacturer put to the thing, but essentially it's collecting all the information through a backhaul. It could be Ethernet or fiber, goes to the cloud, and from the cloud is integrated into the utility software suite or an MDM and the MDM to the utility software suite. The final architecture will be highly dependent on what you want to do, which type of software do you have, and your history, what is already installed. And one of the things that you need to be very, very cognizant is the more integration you put, the more expensive it is. One of the largest one-time cost on any AMI or AMR is these integrations. So if you have different systems and more integrations, the final cost will be higher, and the complexity level, of course, will be higher. Questions up to here? 20 minutes. I think I'm going kind of slow. So each of these systems we describe, PLC two-way, AMR, RF, mesh, etc., have your advantages and disadvantages, but those are not inherent to the technology. It's not that the technology is better than the other. It's based on geography, infrastructure, what's your goals, what you want, and based on that, for certain cases, probably you're going to be better off with a cellular rather than a mesh, or maybe you're going to be perfect with a mesh, and not that well with an RF and vice versa. But it depends mostly about geography, the footprint. If you are in an area that's huge or it's a really big, well, you'll need a ton of repeaters, and a mesh could be very expensive. So you probably are going to be better off with a PLC, a PLC AMI, or a hybrid eventually. So none of this system is better than the other in a vacuum. You need to always consider geography and install base and the assets you have to install the equipment. So with that first part finished, review or recap on all these technologies, uh, I want to talk about the long-term trends so we can identify. First is meters. A meter, if we see a 20-30 year span, used to be a electromechanical apparatus, coils and gears. Now it's an edge computing device. That's the name that the manufacturers give to the meter. It's an electronic meter with a computer, with memory, with two radios or more, firmware. So it's really a computer, probably as powerful as a cell phone. So it's a complex device. That's one of the trends. If you still have old meters, probably are far from being a computer. But if you have a meter that had been bought in the last 2-3 years, probably there's a computer inside. Billing. 20-30 years ago, it was okay just to produce a bill once a month, and that was it. Now we're moving from billing to customer portals and data for the customer. So that's another trend. And in some cases, there's regulations that you need to give the customer certain access to certain information. One that is key, and it's for me is one of the long-term trends that most of the customer don't get a grasp at it yet. We evolved from communication links tied to a function, for example, push to talk. For example, a serial link to a switch, or a fiber just linking two substations. Uh, from those communication links with a function, we move to a network. The network is just one pipe, one network, doing different things, delivering different services. Is the network you have at home. Can connect the phone with the Wi-Fi. You can stream Netflix. You can send email, and if you have a phone connected to the router, you can have even a phone similar to a hardline. Everything is going from one cable, so that affects AMI. They affect SCADA. Why talking about SCADA network and AMI network? It could be just one network. It's an approach and it's valid. And finally, software used to be one software or one complex package. Today, you have multiple software. You have the customer portal, the prepaid system, the OMS, you have the MDM, and certain MDM even have different modules and portals. Each of those imply an integration. So you start having what is called the enterprise bus. It's a system to integrate all those software with your hardware. So these are the long-term trends. It's something that is happening, and we need to be cognizant of that. So that is the the kickstart of this section. This is what we call the utility technology evolution curve. Uh, if you see this, you'll see that there's no timeline here. I'm not putting any years or when something was available. It's just a progression. We started measuring energy 80 years ago with an electromechanical meter. We did manual reads. Then we incorporate certain radios, and you generate these Hertz transmitters. We use walk by, drive by as a standard until suddenly we start having the AMI systems, PLC, two-way PLC, mesh. And a few years ago, we start having these software packages that enable new functions like prepay, customer portals. And now what everybody cherish or praise the AMI 2.0, that is distribution automation, demand response, doing analytics, distributed energy resources, how you're going to control those. And if you see clearly, there's a point in which the function, the initial function that is reading meters, get the readings, and send a bill to the customer, start getting blurred. And we ended up in here that is probably less to do with metering and more doing with managing your grid. So this is start to be all mixed. Any questions around this? Anything that you would love to challenge or you think differently? So, hey.
Hey, I do have a quick question. I kind of see the graph. I noticed that you've got it drawn like it's leveling out, like you're not picking up more stuff, which is interesting. But the other thing I was wondering about is the rate that things are going obsolete in increasing or decreasing? I mean, because we're used to, maybe pulling a meter out, electromechanical meter, it's been there 50 years, and now we're changing meters up in like 12 years, and, we get a new computer every 2 years or a new phone every 2 years. What kind of trend do you see there?
Well, what we're seeing is we quote every month multiple systems, and we review contracts with with utilities and consultants, and still the standard is 10-15 years. If you are going to buy a system like this, you want to be valid and supported for 15 years. And we are signing contract with that clause. That means that the network and the core of the system will be supported for 15 years. There may be the possibility that 7 years down the road, there's a meter with new functionality that can do a little bit more, and it's compatible with the network. So it could be certain as acceleration, but the business, this is my personal view, this is not WESCO, is me. The business will never support the evolution of a cell phone or a computer because it's too expensive. We're talking about a ton of money. And today we have customers that are using meters that are 20 years old and are working pretty well, and they're fulfilling the original goal. So yes, there's a certain acceleration on the features available, but what we are not seeing is an acceleration in adoption. And that is a perfect transition for this slide and the following one. First step is understand your current system and your current investment. And these are the key questions that we normally ask and we love to ask. So the first one is, do you think it's any component in your current system that is going obsolete in 1, 2, 3 years? If positive, okay, you have an issue, and you need to ask another question is, how many years do you think you have to transition orderly? So suppose you still have a TS1 system, a Turtle One working. There's multiple utilities that still have that. Well, they can't buy new stuff. So they have an obsolescence problem. This is today very limited. We are not seeing this problem. It's very, very minimal. If you have this problem and you don't have the money to evolve to a new one, the only option is just to to buy a meter, whatever is the meter, and do a manual read. It's something that you don't want, but it's an outcome, a possible outcome. The second question that you need to ask yourself is the AMR system currently in use able to fulfill the goals we set for our utility? This is our utility. This is the way in which we want to run it. Is the system still valid? Is still the system delivering the goals we want? If the answer is yes, you're fine. You can keep asking this question every year to evaluate the budget and where you want to go. But if the answer is no, there's a second question, and it's not fulfilling the original goals because we have new goals or because the system degraded. And this is important because we are seeing systems that degraded because probably the city grew a lot, you have more meters, and no one put some energy on doing a new propagation study. So you start having meters with no readings, problems. You start moving collectors or gatekeepers from one way to the other, deteriorating the hubs on one side. So in the end, maybe it's a problem. The system degraded because we didn't maintain it well. So that's an honest question to make, and you need to answer that honestly. Probably there's people that retired, and you hire new guys that they didn't pass through all the trainings. So in those cases, this is a very important question to make. Is the system good? Is it still good? Yes or no? And if yes, why? No, why? What is the next step? The third question is regulations. Is there any future regulation that will affect me? For example, time of use. Maybe in 3, 4, 5 years, some states say, well, we want to give our citizens time of use. If you don't have a system that supports time of use and the meter does not support different rates, well, you have another instance in which you need to think about a migration. And around this one, well, we'd love to be prepared for everything, but is it worth it? So sometimes it's a good question to make is, should we forward invest much more than we should because we have an opportunity and we are going to be better prepared for the future? So all valid questions. Finally, grid. Since AMI is seen today as a window to the grid to gather information from these edge devices, the meters, well, is our grid challenged by new loads, or I'm start having a lot of solar or battery storage or wind power, something that I need to manage differently because I'm going to have problems with voltages, moving up or frequency problems. So do I need more insight on my grid? So those are the questions that you need to ask to understand your investments. And look, we are seeing cities that are doing drive-by. They're super happy with drive-by, works perfectly well. They asked this question, said, we're fine. And it's a good system, and it will be supported for a long, long run. And you don't need to spend money going to the latest and greatest just because it's available. That goes to the facts. Those what I call the facts. Every time you talk to a manufacturer, no matter who is the manufacturer, they will show you the latest and greatest technology, the best, the most expensive, the most advanced. The fact that technology is available doesn't mean you really need it. So you need to be cognizant that probably the offer is sometimes much more than what you really need. Third, the systems are large capex, planned for 10 to 15 years and more. So you need to be extremely careful when you decide what to do with the system. You know that better than me again. Another fact, there's always an opportunity to bridge the gap of leapfrog the technology. So we have a case in which customer is using the turtle system and electromechanical meters. So the right thing to do is go to an AMI system, probably jump over AMR. You don't need to follow the curve. You can leapfrog and jump technologies if needed. Uh, Another fact, the fully functional AMI system is a combination of subsystems integrated into one. So you're going to have multiple suppliers coordinated by a prime contractor or a single point of contact. That is another fact. Used to be just one guy. Now probably you need to coordinate 3, 4 different suppliers. Complexity is growing. And finally, an AMI system is a system that is alive, continuously evolving. So you need to maintain, plan the updates as any other hardware or software solution. So if you ask yourself these questions, answer honestly, consider these facts, you're in a good position to understand where you are with your investments. And our recommendation is fully train your staff. It's very common to see uh, functionalities that are available in the system you have that not being used because person that knew how to use it retired. So train people on your systems and shout to the manufacturer, request training, and invest in training. It's amazing how these systems spring back to full 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 capacity just by training people. Check software versions and be on the lookout for new releases. Try to keep it up to date. Normally, we never recommend the last one. Try to be one version behind, so you have time to some other guys testing the new release. Okay, so you don't want to be 4 releases behind, but you don't want to be the early innovator. Make sense? Uh, Check new features. Maybe you have a head-end software that now there's a new feature that you can buy for an extra bucks and solve a problem that you are having. So ask about new features on your existing AMI. Use your support plan to the best of your abilities. Probably your support plan includes training, includes certain things for free. So you need to push the supplier to deliver on those contract terms. Also, when these systems are set up and set into motion and start being used, the suppliers never enable 100% of the functionality. Some functionalities say, okay, as soon as the system is stable, we're going to enable this and this and that. And then routine kicks in, we forget. Maybe there's some functionality that were never enabled and you have it. So that is another way to protect your investment. And finally, ask about new meters compatible with your current system. You don't need to change anything in the system, just onboard a new meter with more functionality. And it's something that we see. There's certain suppliers with networks that have 3, 4 generations of meters working perfectly well on the same network. Questions around this? Okay, so now the final section, 340. Okay, 20 minutes each. We're doing pretty well. So the growing need of data and grid insight. So we all know the challenge ahead: growing demand, more loads, EV charging loads. You're going to start seeing more EVs in the neighborhood. Distributed energy resources, solar, wind, battery energy storage systems, increased need for demand response, and distribution automation. Those are the things that we know we need to prepare for. And in lesser degrees, certain utilities are more advanced because they need it earlier than others. But access to data and software to analyze the data and build the capacity to respond to our challenges ahead will become more critical year after year. This is a fact. year after year, we're going to see more challenges. Yesterday, I was in a conference and I saw data from California, and there's moments in the day that the solar generates more than needed, and there's some plants that need to go idling just because it's impossible to keep. So that's something that we're going to see everywhere. So those are the reasons why we need more grid insight and more data. So one of the ways to get that data is use the AMI network. So again, you have all the meters, the access point, controlling the street lights, go to the head end, and guess what? The most modern AMIs allow you to, with gateways, to connect to relays and control your reclosers, capacitor banks, uh, voltage regulators, you name it. If there's a relay that control the device, you can hook up to a network gateway, DNP3, so you're fully compliant, and you control that over the AMI network. So probably the substation guys will not like it, but it's an option. And some utilities are using this option, using the AMI to get more information on the grid. Um, and if you do that, the software manufacturers and the AMI manufacturers offer what they call the value-added modules. The meter is an edge device, so they meter the energy consumption, but also perform analytics. So think about the meter as a cell phone that you can install apps. Each app will do a different thing. Those apps are called value-added modules. So when you have an AMI system that support intelligent devices, that you can put different apps in there, you can do more things and you can get more data from the AMI system. That data, of course, will go to an MDM where you're going to do your analytics. Edge intelligence combined with software analytics may help utility discover problems and save money. So this is some of the modules that are already available. Electric vehicle detection. There's apps that can detect. There's an EV charging. Low impedance detection. You have a cable that is about to fail. Well, the AMI can tell you, hey, close to this meter and this meter, you have a fault. Phase detection. Transformer load monitoring. It can identify all the loads in the transformer and get a model for that transformer. So that means that you can evaluate transformers, and you may have one that is overloaded, another one that is really very lightly loaded, and you can swap the two, and you prevent buying another one. So these apps tend to save a lot of money. Software to manage distributed energy resources, load management, transformer protection, demand response, and load control. All that can go through an AMI network today. It's a possibility, but not all the utilities use that. But this is something that a modern AMI can do. So if we go to the trends today, there's no clear emerging trend in regards how to use the AMI networks for functions other than metering. So this that you see here, using these gateways, is possible. There may be some guys using, but people prefer to keep the AMI for metering and use the SCADA network and other networks to do distribution automation or getting grid intelligence. But guess what? The fact that you already have a network, is installed and running, makes adding devices simple. Suppose you want to add the capacitor bank, and you don't have the SCADA network close, and you don't want to buy another radio. You already have the network. Just you put the bridge, and you connect the capacitor bank through the AMI network. And the guys working in distribution will be able to operate that. So although it's not a trend, it's a possibility, and you have a network that is fully functional. In the past, latency and bandwidth were a problem. Today, it's not a problem. The most modern networks are super fast, and they can handle the load of these devices. They can operate those with milliseconds and seconds. It's really fast. Of course, SCADA software can add edge devices and sensors as well. It's another way to get grid insight. And finally, one of the most interesting trends in the industry right now when we talk about grid insight is the new low voltage monitoring systems that are becoming available and very, very reasonable prices. Those systems are essentially sensors that you put on a pole and a transformer, and you can capture current, voltage, power. Communication is cellular, goes straight to the cloud, and you have a very simple system that allow you to map completely your network. So that give you options. Instead of building an AMI, very expensive, super sophisticated, you keep your AMR, you keep reading the meters the old way, and you add a low voltage monitoring system to get grid insight. It's another way to do it. So here's how the traditional SCADA system will look like. You have your AMI system, has nothing to do with the SCADA. You have here the SCADA in one of these boxes, and you go to system, and essentially both systems are independent, nothing to do one to the other. This is a low voltage monitoring system. Super simple. You have the sensors and the monitors and the poles and the transformer going to a cellular tower, the cloud, and you can access straight to the cloud. And the only thing this system needs is the GIS integration or SCADA integration if you want to share the information with the SCADA. But you don't need this. You can have the system standalone, and there's a couple installed and working pretty well. This is another option if you decide not to use your AMI to get grid insight. So the final remarks, each utility is unique, and in consequence, the technology evolution will be different for each utility. Your evolution is different from your neighbor based on your needs and your history. There are multiple options to get the end results that you decide. It's not that you need to go to the full-blown AMI system to get grid insight. You can do this in multiple ways. And normally rip and replace is presented as the only option or the right way to go, but hybrid systems or migration or upgrades are very good options before going to a rip and replace. Questions? You want to revisit any slide, go back.
Yeah, I've got a real generic question. It's like 10 years ago when the AMI and AMR stuff really started to come out. Everybody had their own protocol. Everybody had their own communication system. Everybody had, everything was, there was no standards. And, my thought was, well, man, let's just wait this out a little bit and see what kind of standards come out so that, more meters will be able to be in the same system, and there'll be communication systems that are, more generic that can work with different meters and things like that. And, you've done this presentation very, very, very generically. And so, the presentation could be representing something like that. But have you seen that trend where manufacturers are wanting to make things that work with other manufacturers and communication systems that want to work with other people's communication systems? Or are we still in the kind of cowboy Western world where everybody's doing their own thing and still dogging it out for their market share with their particular type?
Look, at, when I see here as today, there's no clear emerging trend in regards how to use the AMI network functions other than metering. The, is more or less the same for the rest. Each manufacturer is going in the same direction. But the good thing is, for example, if we go to networks, uh, all new AMI systems are IPv6 technology. That means is the Ethernet with an IP address of 6 blocks. So there's certain standardization. In regard meters, there's more options for meters as a second source. So um, I try to be very careful, not use brand names. I've never, I didn't mention, I think, in any supplier, but uh, today you can have different meters working for the Landis network, or you can have different meters working for the Itron network, 2 or 3. So you start having second source meters for existing networks, but still manufacturers are very jealous on their networks and their radios. So I I don't see a unified system anytime soon. The only thing that for me is clear is that cellular, little by little, will be the default solution because it's first, it's economies of scale. You're using a cell tower that is subsidized by all of us, because if you have a phone and you're paying a phone bill, you're subsidizing somewhere a larger network. So today you can buy a cellular meter with a plan, communication plan included for 10 years. So, uh, so from a technology standpoint, if it'll be between cellular and IPv6. IPv6 is open by definition. So it shouldn't be that complicated to put a different meter on the same network. But since the firmware is controlled by the manufacturer, um, it's difficult. So I may say it changed, but not that much. It's still kind of the Wild West. Other questions?
There was one uh, note in the chat. I don't know if that it was
Oh,
necessarily a question, but I think that this is kind of a common theme amongst some of our utility members in different cities. Some of our cities that went to AMR, AMI in the early 2000s are now looking at possibly upgrading it. And I know that there's several of our cities in that. So is that something that you're commonly seeing, as that ones that were installed early on to in the early 2000s are now kind of making a move to a new system?
look, I always put the same example. We have customers that are still reading electromechanical meters with postcards
Mm-hmm.
today.
Yeah.
And in the other side, we have guys that every 10 years they have the money to move to with a rip and replace to a brand new system. So we have the two extremes. So the tendency and the trend is uh, try to make upgrades to the new generation meter as easy as possible. That's the trend. But it depends where you're starting. Uh, Today, as I said at the very beginning, today we are signing contracts in which the support for the network is guaranteed for 15 years. That means if you have that network, I'll be selling to you access points and meters compatible for at least 15 years. That give you protection. Your investment is protected from that standpoint. And this is something that is easily verifiable because it's a contract. It's a contract that is it's enforceable. I don't see the change accelerating. I don't see systems lasting less than 7 or 8 years because, as I said, the business is not able to support that.
Yeah. Okay.
It's too expensive to it's like you changing, buying a new car every year. You're not going to do it. It doesn't make any sense. And right now, consultants are pushing for 15 years. And look, we have customers using meters that are 20 years old, and in the same network, adding meters that are last generation, 2, 3 years old. So there's always ways to evolve from the old system to the new one. And it's about asking all those questions, answer honestly, and then plan. If you're going to do a hybrid system, if you're going to move to the new technology, when, and try to draw that path to the future. And again, here is just to keep current with the technology and trends. And I always said I used a flip phone until I was convinced that the BlackBerry was better. I didn't jump to the BlackBerry in the first. And I stick to my BlackBerry until I verify that the iPhone, I think it was a 5 or a 4, was better, And this is the same. The fact that there's a technology out there, it doesn't mean you need to embrace it. It's the same. The electric cars are fun. Yeah, nice. I'd rather put gasoline in mine. Maybe my next car would be an electric. And coming from a guy that sells technology, where I'm selling probably goes against me, but we really believe that you need to use the technology that is the right for you at your time, at your pace, and answering those questions. Is how my future looks like. Should I be prepared for the future? At what extent and at what cost? And if you answer all those carefully, you will be always able to find the solution that is good for you.
Well, sounds like good, solid advice, and we certainly appreciate that, and certainly appreciate you sharing your knowledge with us today, as well as being one of our associate members. Again, it's WESCO. You can find a link on our website, but also I'm sure you can just use your Google or your whatever your favorite search engine is to find it. Any last words before we leave you, Hernan?
As the last word, again, this is our view, and it's the WESCO view, and it's this personal view as well. This a touch of me in the deck is because when we give advice, we're going to give you honest advice. This is what we think, and we're going to take care of you because we have been doing this for 100 years, 100 years, and we take care of utilities, all type of materials. We are there every week, every day, and AMI is a tiny fraction of our relationship with the utilities. So it's something that we do, and we always recommend honestly. So if you have questions, you can call me, put them in, LinkedIn or my email. You have my email. Feel free to call me. If you want to visit, we can visit and explain probably with the more openly about all the options available, and we want to be a trusted advisor.
Sounds good. Well, thank you very much. And thanks to
Thank you.
all of you for joining us. If you need any contact information or the slides or anything, just let me know. If you can't reach out to Hernan. So thank you.
Thank you. Bye.
All right. Bye-bye, everyone.